This is Floss Weekly, episode 789, recorded June 26th. You cannot eat the boards. Hey, this week, Doc joins me and we talk with Igor and Ricardo from the Armbian project. It's all about bringing Debian to every ARM board imaginable and trying to get good support for all of them. You don't want to miss it, so stay tuned. Hey folks, it is time for Floss Weekly. That is the show about free, Libre, and open source software. I'm your host, Jonathan Bennett, and we're going to have a fun time today. We've got the one, the only, Doc Searls with us. Hey Doc, how you doing?
That may be one too many, I don't know, but yeah, I'm fine.
One too many, listen to this guy. I'm good. It's good to have you back in the secondary hot seat, as it were.
It's still warm.
It's still warm. There you go. I like that. So today we've got the folks from Armbian. That is the Debian on ARM, and I think some other things. Maybe RISC-V. We'll have to ask. Are you familiar with Armbian, Doc, or is this uncharted territory? You are now.
I am now. And it's funny, when I first looked at it, it was a tiny print, and I thought, Armbian, that's interesting. Why did they name it after a drug?
No, not quite.
Not quite.
Yeah, so yeah. It's going to be a lot of fun. It's going to be really interesting. But of course, it is sort of one of the kind of premier Linux distros for ARM, and the list of boards that they support is really impressive. I'm going to have to put a bug in their ear about adding a board to their list, because I'm sure they get this all the time. People are like, hey, why don't you support this or that? And, there are reasons. We'll ask them about that. Let's go ahead and not waste any more time. Let's go ahead and bring them on. So we've got Igor and we've got Ricardo. And I want to say, welcome to the show, guys.
Hello.
Welcome.
Hello. Hi.
Hey,
Thanks for having us.
Yeah, it's gonna be a lot of fun. I'm looking forward to it. So I want two questions, and I'm not sure which order to put these in, because they both kind of depend upon each other. Give us first, I guess, one of you take it, the 30,000-foot view of what Armbian is and why somebody would reach for it. And then the other question that sort of goes with this is, what role do each of you play in the project?
Well, okay, let me try to do some very quick introduction. Mm-hmm. So Armbian is like a base operating system for single-board computers. Mm-hmm. That would be like a definition, but it's a lot more, actually. It has a very strong build framework, which allows us to build images from sources. And customization in this process is really extreme. So we provide small IoT, let's say, very minimal images, server images, and several desktop variants. Also we implement all available technologies like video acceleration, that kind of stuff. Armbian, it has really extreme diversity at the source point. So all the hardware has some specialities, different bootloaders, different way how to put things together. So at the end, for the user, it looks the same. So this challenge is really still is, but it used to be much bigger in the past, because the development of the basic SDK was really, really poor. Now it's getting better, but still it's a challenge to bring, like you mentioned, if you want to bring new hardware, new custom hardware, we say this is more like a custom hardware world, it's quite a lot of work. So it's not that simple to add a new hardware to Armbian. But once the hardware is in Armbian, it's quite easy to change it to some other distro. So that switch is like a very simple. So
Yeah, we could say that Armbian, essentially, if you ask the users, it's a Linux distro, right? So a typical user, you ask him what is Armbian, it's, well, something like Debian or Ubuntu, but it's made for my single board computer. And for this perspective, it's something that he could go online, find an image, right, that he flashes to an SD card and actually gets that board booted, which seems simple enough. If you're coming from a Raspberry Pi kind of thing, that's very obvious, right? You go to Raspbian, you get a download, you flash it with the image flasher, and you boot it. So Armbian is essentially, if you look at the code of what Armbian is, it's an image builder. So it's a build system that is able to compile all the bits necessary for those boards. And that's starting from the infamous blob, and then the bootloader, and then the kernel, and then user space on top of this. And so Armbian was born mostly as a giant script that did build all these parts and made them work together. And later it evolved into being a distribution. So it not only builds the images that you can download and boot, but it also builds and maintains package repositories so that you can then upgrade your packages and maintain them up to date. So it's essentially a Debian Ubuntu derivative, but with very specific parts for those components that are not covered by other OSs. For example, Ubuntu has support for a few SBCs. Debian has support for a few SBCs. Armbian is building currently for 240 different boards. So it's, there's a whole mishmash. And the big challenge about Armbian is managing this diversity and this complexity. And not let that lose control, and especially once a board is in or a SOC family is in, then we try to keep that updated and provide LTS kernels, updated security updates, that kind of thing.
Okay, I have a bunch of questions, place I want to go, but first I do want to ask. I tried to give you guys a 2 for question. That didn't work. It didn't work. So let's start with Ricardo. What is your sort of how do you fit into the project? And then once you're done, we'll go back to Igor.
Yeah. So right now I'm doing this mostly part-time. Right. It's I'm not really dedicated into this, but a few years ago I dedicated a couple of years, essentially 2 years, to completely or almost completely rewriting the build system. So I consider myself the lead developer on the build system. That does not mean that I'm a kernel hacker or a bootloader hacker. So I know how to build these things, and I know a few of those families. So Rockship, some MLogic. I have an idea about them, but I have no idea about Allwinner, for example, which is a very, very popular family inside. So I came to Armbian essentially because in my day job in the years before, I was building cloud images, Debian cloud images and Ubuntu cloud images for running on clouds, right? And that was essentially the bootstrap and that kind of stuff. And then I found Armbian when I got aboard and said, well, this is I can shoehorn this to produce cloud images. But then I made a fork, and once I did a fork, then nobody would take my pull request because it then made Armbian build cloud images. So I then started doing transforming that huge amount of bash into something extensible, and not just by having scripts, but by really having a framework that allows us to customize different points in that build system. And then later we made it distributed, so we can build the separate parts. So we can build, today we're building about 600 bootloaders, 57 kernels, and this can be distributed. So my thing is really, my approach is really looking this from a mile high and trying to understand what is needed for the real experts, real kernel experts inside each of those boards and families, so that they can do real good work and have tooling available to them so they can maintain this over time with minimal effort.
Yep. All right, Igor, same question.
Okay, my current role is more like more in management of the project. So project management as a whole, business development, taking care of people, their needs, about the internal group. That kind of tasks. But in the development, I'm more involved in automation. So in developing and maintaining automation for these systems. I'm involving new people to help me in this automation. Also, I'm still overlooking the build framework maintenance. So like a main reviewer, kind of, but I'm not developing much in this segment anymore. Before I was I'm that guy who made that initial script back years back, like it's almost 10 years back now, where everything started, and then where also this community started to build around. So we started with cheap Chinese SBCs based on Allwinner. So I'm, on the other hand, more acquainted with Allwinner than Rockchip and then or Raspberry Pi or others. So Allwinner I spent many years, and we have quite a big team around those chips, and also today more around Rockchips. So my role is
founder.
Founder, yes. But let's
creator and founder. Come on.
Yeah, of course, yes. But I'm still moving it as a full-time job now for 2 years. It was impossible to I would say eventually it became impossible to do this kind of work on a side. So my full-time job was start to fall apart. So I'll say.
So I'm wondering how many single board devices do both of you have laying around that you work on, and where do you keep them? Because you have nice looking surroundings there, and my guess is you have a workshop or a garage that's full of these things.
If you can see mine here, well, there's about 12 boards going on there. You can see Linux heartbeats there. But I have a lot more. This really gets out of hand very quickly.
Yes.
At the beginning, you start getting, you get a board somewhere. I started with a TV box. We can talk about that later. But then, you get one board, then you buy one more, then someone sends you another one, then a friend can't get one to work, and then it sends. Well, I don't know. I have a few dozen. Yeah.
Yeah, my number is unknown, so I would say I have.
We lost track.
Yeah.
Yes. I have I have one big box where it says retro. So I put there single board computers which are already for museum, let's say. I don't deal with them anymore, but then I have a full size rack. It's in the other room. There are plenty of those boards, but they are in action. So I'm running a test operation there. So all the code that is changed every day goes to those boards, and we see what's happening. So it's a test facility. So there are around 50 boards currently that are running.
So I work some with ARM boards. I do some things. I have some Raspberry Pis, and I got started way back in the day with the Beagle board. I think the Beagle Bone was one of the first ones that I worked with, and I have sort of an observation, and that is the boot process on ARM boards is terrible. Have you experienced this too, or is it just me?
Yeah, it is complex. So essentially, these boards you can take them into three big categories, right? So something that boots and has a proper UEFI ACPI firmware, so based on usually DK2, Tiano Core, and those are very, very restricted. So those are really for big server boards. So all the Amperes, 128 cores, those have proper UEFI firmware. So they can boot generic operating systems. Say you can just get Ubuntu ISO and put it in and it will boot. Will it work perfectly? You don't know, but it will boot, right? Yeah. And there are boards. They're essentially based on U-boot. So U-boot is this very popular open source project. Most of those boards at the SDK level, so at the silicon designer level, have been brought up using U-boot. And then you have a very small number of boards that represent a very large amount of users, which is the Raspberry Pi, which has Broadcom-specific bootloaders, which is different from all this that I said. So those are, I might be forgetting some here and there, but those are the main things. So if you're doing the Raspberry Pi and you're doing the Raspberry Pi the way it's intended to do, is very easy and it works. If you have the UEFI boards, server boards, they call it server ready certified or something like that, then it's just UEFI. You're going to have troubles with the ACPI tables and other PCI stuff, and then your GPU won't work, but it will boot. But then this large majority of those boards fits into the U-boot category. And then that's not only U-boot, because you need also firmware, the blob, right? So this is mostly closed source provided by the silicon vendors, or in some cases, fully open source. But then that gets extra complex. So the main thing about those boards is you really need a way to get into their console. And this is about UARTs, right? Serial consoles. And if you set that up correctly, then, well, you can watch it boot. Otherwise, you have to wait and hope that the bootloader works and it brings up the kernel so that you can get some HDMI display.
Yes.
And if it doesn't boot, then you're lost. So yeah, it gets intricate. You really need low-level access to the board to be able to debug it and then understand what's going on.
Yeah, yeah. So I've observed that we kind of see more of the UEFI starting to come to even smaller boards. And one of the interesting things is people are doing UEFI shims, essentially, where they'll write something that maybe U-boot will boot, or even for the Raspberry Pi this exists. You know, it'll boot through the the proprietary Broadcom system, and then it is a little tiny piece that then gives you UEFI. And so that sort of seems to be the direction that things are moving. And I've got to say, like, as an end user, UEFI makes things easier. It really does.
Oh, for sure.
You get grub, you get all sorts of stuff that just starts working the way that you expect Linux to work.
For sure.
But it fascinates me that you say that it's such a pain to work with. That I didn't expect that.
It's not really a pain to work with. What I mean is, usually if you buy an x86 PC, you just assume that your BIOS works, right?
Yes.
And sometimes you need to flash it. Oh, there's a support for some new RAM, but usually it just works, right? This is not absolutely. I can't say this is 100% true on the ARM side of things. It is on the very professional server boards where everything's tested and validated. But for the smaller boards at lower costs, they simply isn't there yet. So this EDK2 project is really catching up, especially on the Rockchip platforms. So the 35.6X and the 3588 boards have really good support for EDK2, which is a complete UEFI firmware which can access all the devices, can boot from the network, can boot from SATA, can boot from NVMe, and this kind of stuff. If you go to Raspberry Pi, you can put a SD card with the UEFI firmware on it, so it boots its internal bootloader and then chain loads EDK2, and then everything works. But is it booting from the SD and then later loading the OS from a USB? So it's not really built into that. It's completely different if you buy an Ampere server, or it just the firmware is there. It's open source, It really has been tested, and they are ironing out all the kinks to the point that it can boot Windows on ARM, right? It really goes into there. But really, it's much heavier. It's much harder to work with. It's C++, if I'm not mistaken. So if you're developing something for those boards, you usually don't need the UFI thing. If you're doing some IoT project, U-boot is going to get your kernel loaded faster and a more consistent way, simpler, right? So yeah, it does depend a lot on the use case. But most of those boards are still on U-boot. Right. We've done in Armbian some experiments, some experimental images using EDK2, especially for the rock ships, and they work fine. But we're not ready yet to commit. There's a very large investment in U-boot, right? And we're very few guys supporting this, so it's not the time yet to move completely. Even if we could, that would be addressing about 20 or 30 boards out of the 240.
So I'm curious, and maybe this was a better question for Igor. What does the process look like to get a board added to Armbian? So I'm imagining that somebody makes a new issue in the GitHub and says, "Hey, I've got this cool board. Why don't you guys support it?" And you hope your users are nice, but sometimes they're not as nice as you would like. Is there some process where you say, if you send us one, we'll probably be able to support it? Or give us SSH access into your board and we'll try to support it. Is there some kind of standardized process you guys have?
Well, it's a bit difficult because you need to allocate resources. So if you don't have resources, I would say the team, the people who are currently working on the project or maintaining some hardware is already over to the top with everything. So I ask guys, it's usually hardware dealers that are sending us some samples, or so they are showing, do you want to take this board, do you want to look on it? It's not coming from users that much, also from users as well, but I ask, and if there is no answer, if nobody will take it, there is nothing I can do, I would say, because I have on the other side people who will bring up if they can pay the bills with this. So, but if there is some strange, weird hardware that only one user has, it's too expensive to start. So we cannot cover this. It's really difficult. I mean, and you need the hardware, and you need some support from vendor as well. Yeah. Okay. Go ahead.
Igor, once Igor has your address, he sends you boards you didn't ask for.
I don't do that.
No, yes. It's not true. It just happens by accident sometimes.
Okay, once I did.
No, really. From a technical perspective, usually the board vendor, right, the guys who are doing the PCBs, they bought the SoC from someone, right, from some silicon vendor. These guys have an SDK. Usually very old Linux, very old U-boot. They bring it up, they send it over and say, hey, good luck with this. So essentially, the more common to that nowadays is that some user takes that, ports that into some kind of more mainline-ish format, and then submits a pull request. So it's usually a hobbyist user that is, knows enough about this stuff to do this. Sometimes it's developers, just random developers in our community find a board at a conference or something like that, and then bring it up. But yeah, it's mostly pull request oriented. There have been some cases where, a vendor came and said, I'll send you 5 of those boards, will you bring it up? I find that fine, but I also find that I cannot eat the boards. Is what I mean. They're awesome boards, but I cannot eat them. So
yeah, mine Bitcoin on them to pay for food. Have you had vendors actually offer to cover your time, to pay you money to do the bring up?
Yes, in few cases, yes.
Yeah, that's always handy.
Yeah, but it's not that good still. So.
Sure. So is Armbian running mainline on all boards, any boards? Is there this massive pile of stinking weird patches that you guys have to apply on top of mainline? How does the kernel side work?
Well,
Yeah,
it's
it
not.
depends, right?
Yeah,
It depends.
It's not smelly patches because most of them are ours. No joke.
I write code. My code is sometimes smelly. You can admit to it. It's fine. No judgment here.
I know. No, just yes, of course, it's heavily patched mainline kernel. So, and again, it depends on which family. So we have Allwinner, which is massively patched, and we have Rockchip, which is a little bit less, and then we have several which are just a few patches on top of mainline. So that gives you also the status of mainline kernel by let's say SoC family, and also the interest on the other hand. So if you have small users, you also find less problems and you have less patches. So
yeah,
it's connected.
It also depends a lot, essentially, on the age of the board and the interest it generated. So when it got added, very likely, I'm going to generalize, but it got added using a vendor kernel, which is not just an old mainline kernel. It's an old kernel that has been heavily hacked upon by the vendor. That means that if I take that same vendor source and try to run it on a standard machine, it won't run because it has been hacked at, right? So usually, sometimes, especially new SoCs are added in that way. And then as the work starts on the mainline kernel, then there's a whole bring up that it's very basic stuff like clocks and pin controllers and this kind of stuff. Once that gets the first lump, right, then we can add the mainline kernel support, which has probably can bring up a few CPUs, can bring up the RAM, can boot and have a serial console. It won't have Ethernet, it won't have HDMI, it won't have anything. So this is the situation with the latest Rockships, for example. Was 2 years ago, we could get some decent experience using a vendor kernel that was completely out of date and insecure, or we could get a serial console on mainline. 2 years have passed, and now we can get almost a great experience on mainline. So this has been done mostly by people outside of Armbian, but also by Armbian developers themselves. And Armbian has been this channel to expose a lot of users to this without them having to go pull from a crazy Git tree somewhere. Yeah. No, they just pull Armbian and say, build me whatever is the latest that you guys can have about this, right? So for each board, we do have a few, we call them branches. They're not really branches. But essentially, we have a version of the thing that's called legacy or vendor, which is essentially the SDK supplied by the vendor, sometimes with some fixes. Then we have something called current. Current is usually LTS mainline kernel. So currently would be 6.6 or 6.1 in some cases.
6.6.
And then we have an edge branch, which is where the action happens, right? So this is currently at 6.10 RC5 or something for most boards. So this is really a bleeding edge and trying to bring the latest and greatest, not only from the main line, but also with patches on top. So it's like really dual headed serpent there.
Yeah, so I have noted that vendor kernels are terrible. And you look at some of them sometimes and it's like, are you guys not ashamed to have pushed this? Like, it's so old and it's so bad. What I can't figure out is why more vendors don't work with the upstream kernel to try to get their patches upstreamed. It seems like it would be such a smaller maintenance burden on them rather than trying to bring this 5-year-old kernel tree along for every revision that they've got. Just, I really don't understand why there isn't more effort from the people actually making these things to get their code upstreamed.
Yeah, and even you see a few vendors which are not there. They're not upstream first, right? Which is essentially what Google is a bit forcing Qualcomm to do. So you guys want to do on the Chromebook, so you got to be upstream even before the silicon is ready for consumption. So that's the ideal world when you have some big company like Google setting the rules, and then those vendors are forced to do it. But we do have a few vendors that are at least trying to get a bit closer, or at least trying to work on an LTS kernel and then backport the fixes actually, so that you're not completely out of a support. But it's pretty rare. So these guys have this embedded mentality, which you do one kernel, you ship it off into a device, and you never touch it again.
Yeah.
So it's really about their mentality. It's about where they put their money and development. And of course, you're submitting patches to the Linux mailing list. People are gonna look at it and gonna tell you to change your stuff, right? And
don't send me this.
Right. So these vendors want to get out something that they can demo and show how many FPS or whatever it does. They don't care about making a maintainable code. So they don't have the financial incentive, because saying, oh, we're mainline first is nice, but it doesn't get the demos and the FPSs and whatever.
It's difficult to control this for them. So they have a SoC. They got a kernel which SoC vendor is kind of supporting, and they are paying for that support, and they don't want to spend anything more than that. And so for some, I would say, specific use case for IoT, for industry, they need one feature or two features to work, and they are totally happy with that. So they will not invest into new kernel because old is good enough. So my TV is running kernel 4.14, and it will never be updated. And all those devices, IoT devices, are the same. And there is little we can do, but we are pushing, let's say, mainline, and we are getting, let's say, interest from not just from end users, also from industry who are having those weird all-winner or rock chip devices. Can you maintain a mainline kernel for us? Because this mainline code, which is up there, let's say upstream, is also not something that always works. If nobody is maintaining certain sections, it starts to collapse. And this is what industry is afraid of. So it doesn't work. So
Yeah.
So I'm wondering, how do you guys support yourselves? What is your business, or is it a different business for each of you? And do you have a side gig, or is there money in this? I'm not clear on the economics of your lives.
Well, Ricardo has a job. I am here full time. Let's say I invested some of let's say my savings into this. So the company is providing support, so professional support services. So we have, let's say, few support deals, and that keeps us running. Of course, we got donations and that stuff, but that doesn't pay the bill. So.
Yeah, and from my side, like I said, I cannot eat the boards, right? They try to pay me with boards, but that doesn't really work out. But to be fair, I did get a few years ago more than one job engagement using Armbian as a base and coming from Armbian, right? So someone found a video on YouTube that showed some of the boards that I brought up. Someone in California said, well, I can use this for this audio project. This board is really interesting. I got hired, got a good gig doing that for, I don't know, a couple months. So yeah, I do get some gigs out of this, but yeah, I have really no intention on the involvement in Armbian and the build system proper is really a community effort, right? There's no money there.
Yeah,
and I can't eat the boards.
I'm curious. We've got the UK and the EU. They're starting to pass regulations and passing laws to try to make IoT things more secure. Does that have an impact on you guys? And I guess you could imagine an impact like directly on Armbian, but I'm actually hoping that this is going to have kind of a secondary impact on Armbian, where maybe it forces more vendors to look at sort of the development that you guys do. Is there any interplay between Armbian and some of these new regulations?
No, but we were involved. I would say we tried to be involved because we didn't. The project didn't start it, but related to security, there was some I would say foundation gave out some funds to improve security in the OS level, and they provided some funds for it. We tried to apply for that, but we didn't came through. So, it was, the point was to, so it was security, title was security, and there was some European funds, whatever, I don't know, to improve.
Yeah, the NGOs come up with some funds for those, and sometimes we can get some of that, but not much really. It's really the IoT aspect of this is the interesting part, is because Armbian is a general purpose operating system, right? It's just like Debian or Ubuntu. So, okay, you can have a minimal image, and you can have a CLI server image, and you can have a full desktop image, for example. But that's not where the power lies. The power lies in the build system and its extension framework. So this really gets people who get one of those boards and say, well, I want to make a product out of this, right? And then they can customize that image and trim away what they don't need, add what they need on top of this, and then it becomes like that company's IoT project. So Armbian really doesn't really have too many features in the final images that you can go and download for IoT. But it is really in the development process, in the build process, and when you get hands-on with the build system, where you get the value out of this. And this comes essentially because it makes it very easy for people who, well, I can get this Debian Ubuntu going, and now I just need an audio player, right? I need an audio player that auto starts when it boots, right? And there you go, you have an appliance, and that's an IoT project, right?
We got I think two projects from industry that they were interesting in switching from Yocto to Armbian. That was so they came to us and they say, "Can you help us? We have this Yocto thing, this BSP, whatever." But our customers, so their customers were saying this SDK is so complex. So if they want to change something in the OS, it's really painful. But Armbian provides this really simple. So it's really simple to change something, to add something, rebuild image, and flash it to the device. So this process is much less complicated than Yocto, for example. Yocto, you really need to learn. You really need to invest some time. I think with Armbian, I don't know, Ricardo, how fast you think a new person can let's say developer,
depending on what is your IoT project, right? Depending on what it is, and is your base software packaged already in Debian or Ubuntu, and is your kernel already brought up, and your U-boot is already working? So it's really just glue code, essentially saying instead of when you bring up, you're going to bring up a generic desktop, you're going to bring up something that is like a kiosk mode, something, for example, or something that doesn't even use a display, just outputs audio or read sensors, or and then there's, of course, some companies need more of this, so they need over-the-air reprovisioning of those images. They need metrics, right? So they want to collect telemetry data from this. So yeah, it really becomes quite disconnected from the original image at a certain point. But it should
they can use build system.
really be simple. So I've seen prototypes being built in 2 days for audio stuff. So it's really, really cool, interesting stuff.
So I'm curious, the name Armbian obviously suggests that you guys are very much ARM focused. I'm curious if you have some support for things like the Star 5, the Civision 5 2, which really is one of the first RISC boards that's actually usable a little bit more than a toy. You can actually, if you really wanted to, you can compile on the board, which I think is an interesting thing. Is there RISC support in Armbian? Is there MIPS support in Armbian? You know, are any of these other esoteric sort of?
No, we didn't go further. So actually, we start with ARM first with ARM 32-bit HF. Let's say the back in the days. Then it was upgraded to ARM 64, and then Ricardo came to the idea that x86 would also be good to have. So it was added x86. I'm running it on my laptops, on my servers. So, and of course, RISC 5. We have the support exists. We have, I think, 2 boards that are officially supported. I don't know if this one is among those, but there are not that many different chips anyway today. So
yeah.
So I was guilty of adding the x86 support to Armbian, which made it AM Debian or whatever. And then, some other folks that got really into the Vision 5 initially, they started sending some patches, and then I had to add build system support for this because the tool chains are different, and there's no TFA, it's SBI, and there's a lot of smaller things to be done on the build system side, so I integrated those. I actually don't have any RISC-V boards running, but I added support for a half a dozen. So, and that really is the case. I'm just trying out the build system and then let those guys build images and see if they work. I hear they work, but I never saw them work myself. So it's really, I haven't had any focus on the RISC-V side of things. They are interesting future-wise, but I haven't seen one that I said, oh, this one, I want to have it myself yet.
Yeah.
But yeah,
Yeah, we are currently working on one 8-core. I don't know what is the Banana Pi F3.
Oh yeah, the F3. Yes,
this
that's 8 cores, so it starts looking interesting. I personally not interested in things that have much less than 8 gigs of RAM. So my audio board today has 16 gigs of RAM. So yeah, unless it hits that sweet spot for me, 8 cores, 16 gigs of RAM, I personally have little interest in them.
I don't know how many memory actually this one has. Is it 8 only, or?
I think it goes up to 16. Yeah.
I'm curious about what your users are doing. I mean, what are the typical uses of these boards as they go out there? There must be some sort of, main use, or maybe it's just all over the place. But there must be some interesting stories about it too. So, but that's usually the question Jonathan asks.
It's all right.
Oh, there's a lot. There's users running a CLI application. So they're doing stuff like running Home Assistant, for example. So Home Assistant itself supports a few boards that they sell or support directly in the Home Assistant OS. But using Armbian, you can get almost any of those 240 boards and run Home Assistant on them. So that's very popular. And I mentioned Home Assistant, but there are others, of course, right? The DNS filtering thing, Pi-hole. Many others. So this auxiliary kind of things, or run a router or a firewall, that kind of stuff. That's very popular. And I think there are users.
OMV.
Yeah,
NAS,
for NAS situations. So people getting those boards, and then you can hook up a lot of SATA disks or NVMe disks to them, and running a NAS solution like Open Media Vault. based on the Armbian kernel. That's very popular. And then on the more recent, more powerful boards, they have GPUs and faster cores. There's a lot of users actually using them as daily drivers as desktops, right? So they're doing. We built some KDE Neon Plasma 6 images that were very, very popular a few months ago. So those get actual 3D acceleration. They get using the vendor kernels. They get video acceleration. So those are really starting to get really good to run as a very cheap desktop, a very power efficient desktop. So there's of course a lot of people in the middle I'm not mentioning here, but it's either people running really headless CLI applications or desktop stuff, I think.
I'm also wondering about, I'm involved in endless conversations about personal AI and having an AI appliance that people will need an AI appliance of some sort. Now that would seem to me that would require a specialized graphics chip or something like that in it, but I don't know, maybe in the ARM world, I'm not familiar enough with it. So is AI on your radar at all in terms of what people are wanting?
I don't know, but I think yes. Yeah. It's a hot topic. That's the reason, and some of those boards are coming with chips for AE acceleration, but on very basic with basic capacity, I would say. So they're not so powerful, but I don't know what they are used, what they can use before.
I'm doing AI at the day job, right? Using those very, 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 very expensive NVIDIA cards. So running cards that have 80 gigs of video RAM, for example. So for really large language models, there's nothing even remotely similar at the ARM. Of course, if you get one of those big Ampere servers, you can plug in an NVIDIA card into it and it will work. So you can get one NVIDIA card running on an ARM board. But if you look at those smaller boards that have GPUs in the SoC, those are really much different and much less powerful and have shared memory. So they're really not adequate. The interesting thing is that some of the new boards, so the latest, not the latest, but the second latest generation from M-Logic, and the latest ones from Rockchip, they have what they call an NPU. So it's a numeric thing. So those are specific for inference. You cannot train models on them, but you can run an infer against them. So usually very useful for especially those boards that have multiple connectors for cameras, for example. So you can do object detection in real time. But this is really only starting to show up in the mainline kernel, and some of those get really, really interesting because they are similar to the GPU cores in the same SoC. So the drivers for this are being added by Tomeu Viçoso, used to be a Collabora guy and now has been working with Libre Computer for this. They're being added into Mesa. So it's really fascinating to see how this is going. There's not really a super standard API, either at the kernel level or at the user space level. So, okay, maybe TensorFlow has this aspect of, but it's really very fragmented right now. Those boards do have 6 flops NPUs, 5 flops NPUs, so they're decent enough for, especially for those image processing use cases. That is actually more like machine learning than proper AI, right? It's no usually I associate AI with the large language models, and those can run on the CPU as well. So especially on those machines that have 16, 32 gigs of RAM. You can infer those models and run them actually on the CPU using stuff like Olama and other open source projects as well. It's pretty interesting.
Yeah, Viçoso's he calls it the rocket. Let's see, what was the rest of that? The rocket accelerator. That's it. And he's got
the Rockchip one.
Yeah, for the latest Rockchip, and he's got a demo of it doing real-time object detection at reasonably fast frame rate too. That is actually pretty impressive. The fact that that's mainline, like we're not depending upon a vendor kernel with that, and it's actually running in Mesa. That made me feel really good when I saw that. Just a little bit of hope for the world.
Yeah, and he did the Vivanti one from in the Logics. They call it Etna Viv, which is just Vivanti. I'll backwards.
Yes.
Yeah, and that works pretty great. And that is the full stack is out, so you can get both the kernel and the Mesa part. So CL, you can actually run the models. The Rocket stuff, I think it's too cutting edge still. It's bleeding edge, so it's just being sent to the kernel mailing list. I don't know how the user space is.
It's very new.
Visoso is doing a fantastic job, and I hope more people sponsor him to keep on doing it.
I'm wondering, it feels to me, being old and having been around before even the PC was there, that the AI world sounds to me a lot like the mainframe world sounded in 1974, when you couldn't. Everything had to run on a terminal, and the idea of personal computing was oxymoronic. It was like it made no sense because there was no such thing yet. And yet, I think the primary use in the long run for AI is going to be ordinary things in users' lives. For me, one of my examples is. What are all the property that I have? Where did I leave this thing? Where was I 3 weeks ago Thursday? What route did I take to get to some place? I know a lot of this data is in the hands of giants that I don't have it, but a lot of it is laying around here. Like just getting. I don't know if you have this problem, but if your credit card bill has Amazon on it, it doesn't line up with Amazon's record of what it sent you because it accounts for it differently. The bottom number is the same. I want an AI to do the algebra on that and do the logic to figure out, oh, wait a minute, that was a business expense, that wasn't. And there's just a lot of stuff in our everyday lives that's out of control that an AI would help with. And interestingly, I don't think our desktop computers are made for that. I think they may need some kind of network attached, something else that can handle that stuff in a dedicated way. And also selectively disclose data about me to the marketplace on an as-needed basis as well. I don't know if you guys have thought about that at all, but it seems to me that's sort of like the unexplored part of AI at this point. Everybody's sort of like modeling their idea on, gee, you need giant server farms, you need this expensive NVIDIA boards, and the rest of it.
Yeah, but you do need them. That's the point. So those
you need them for some things, right? Not for everything.
Yeah, especially if you're training models, right? So if you have this set of data, it's labeled manually. You don't ask by whom, but it's labeled, and then you need to process this training of those models, into something that can run. You really need those, especially the VRAM is really important. So this is not the same DDR4 or 5 RAM you have in your PC. This is 2 orders of magnitude faster. So yes, they're expensive, but once those things are trained, you can do inference on quite commodity hardware, right? So you can do them on the CPUs. Just check out Llama, for example. You can get running with those Llama 3, Gemma, and other models from the big players, right?
Because they're pre-trained, as it were. Right?
Yeah, they are pre-trained, exactly.
Yeah. So
if you're really working in this area, you're training your own models, and then that changes the thing. That's why NVIDIA is so far ahead. It really is about the APIs that you use to program against, so CUDA and this kind of stuff. So there's really at the beginning of this. There's no effort to standardize any of this yet, because its value hasn't even been proved completely yet. So why standardize an API for this? It's very, very proprietary stuff right now.
So Mashed Potato
No open source at all.
Yeah, Mashed Potato in our live chat says, Doc, have you considered Microsoft's recall for this?
Exactly. Oh, wow.
So that's funny, though, because what you're talking about is sort of the same thing that Microsoft was trying to tap into with recall. The problem is the way that Microsoft did it by taking screenshots. Now, there's the security problems and all that, but they tapped into the creep factor. It's creepy that an AI is taking screenshots of everything you're doing. Yeah, somebody dropped the ball on that one.
Yeah, and I can go to ChatGPT and ask it to write a device tree from vendor kernel to mainline, and it hallucinates so beautifully. Yes. It's like it really has no idea what a device tree is or what a kernel driver is. It's really it's fine for really basic stuff, but
all it's doing is it's putting
doesn't serve Armbian at all.
It's putting letters and characters into the same order that sort of resembles the other things labeled device tree that it's seen in the past, and that's not very useful.
It's funny. I gave a talk here at the university where I'm attached, and it was actually about the history of open source and the history of standards, of internet standards, and most internet standards are with the IETF now, and the IETF has these RFCs, requests for comment, and each standard is kind of attached to an RFC. So I said, make me a table, this is ChatGPT, which has the RFCs on the columns, and it has standards or uses, down the left. It had about at least half the RFCs wrong, and the dates wrong, but the stuff it put in the boxes of what it did was like, that's half right, but I realized I created an enormous amount of work for myself with that, and I got rid of it, actually. And I came away thinking, hallucinate is the wrong word. Bullshit is the right word, because that's exactly what it is. They're bullshitting. They're making stuff up, and it knows to the degree it has knowledge that is. I don't have an answer here. A human being will say, that's a good question in order to buy time, and then say, I don't have an answer. But, with these things, like, I'm going to give you an answer. It could be anything, right? And
if you look at this kind of stuff, so the Raspberry Pi 5 now has a PCI exposed thing, right? We've exposed full-size PCI exposed on the stuff like the Rock Pro 64 since 2018. Right, so it must hit critical mass with the user. So now the Raspberry has a thing. Yeah, but other stuff had that years ago. Why didn't anyone commemorate this at all? So this AI thing will also, I think, settle once it reaches a certain point. Right, right now it's all too new and all too impressive. With that main thing, don't assume that what you saw that specific demo work extremely well for will also work for your use case.
Yeah.
Right. So the demos are impressive. When you get to actually, everyone wants to deploy AI in their companies. Nobody actually wants to talk to an AI in their personal life. But,
yeah, that's true.
And an interesting thing with AI too is that if you want a clear answer to something, you don't want a different answer the next time you ask it, right? You want it to be the same. It is never the same. You want it to draw you a green field with people on it, and the people have balloons. And you ask it to draw it again, but without the balloons, and you get a brown field with completely different people and 3 balloons because you use the word balloon. I mean, I'm just making this up, but that's... it is early days for sure.
Yep.
Yeah.
All right. So there is something else I wanted to make sure and get to before we let everybody go, because we've been talking almost an hour. Imagine that. So I've gotten excited about different boards multiple times. I mentioned I started with the BeagleBone. For a while, I spent some time trying to get the what were they called? The Utilite boards, I think was the name of them. This has been years ago, like 10 years back. But
I heard about, but I don't recall what is the
hardware. Yeah, they were they were Vivante was the GPU on them, and I spent,
IMX.
They're IMX boards. And there's been several times that I've seen boards and it's like, oh, this is really cool. And then, you'll get a post from somebody like Fedora saying, hey, we support this now. And it's like, yes, a mainline distribution supports it. I'm going to go buy one of these and use it for, what have you, a set-top box, all kinds of plans that I've had in the past that I want to use one of these little ARM boards for, because they're tiny and they'll fit anywhere. And almost without fail, you buy the board, you get it in, you follow the instructions from Fedora or Ubuntu or whoever it is, and either it just fails to work completely, or you're stuck forever on a terribly old kernel, or they forgot to mention that they have no HDMI output, or there's always been something that's broken about it. And I have just sort of given up and just started using Raspberry Pis for everything with the Raspberry Pi OS, because my experience there has been that stuff just works the way that it's supposed to on the Raspberry Pi.
We try to divide, let's say, hardware that will work almost always. So we call this like a standard support, and everything else is like unowned, uncharted territory. Because if we don't have a maintainer that will take care of this, that when kernel changes, he needs to check if board still works. Otherwise, it is possible that you will have exactly the same experience which you just described. Described that something will not work. You will need to push it manually. You will need to hack it together. That it will boot up eventually, or there will be some errors. The kernel will crash or something like that. So we actually narrow this whole giant 200, 300 boards down to, I don't know, 50 or even less, which we keep an eye on it. And there you should be pretty, the experience should be pretty solid. So like download, flash, burn, run.
Yeah, and the funny thing is, if you get any of these, let's call XYZ boards. So if you type into Google XYZ HDMI doesn't work, I bet the first result will be Armbian with some solution, right? On the forum or on an issue on GitHub or this stuff, we have support for boards that have been abandoned completely by the vendor. I'm not going to name them.
They
but
don't
there's
exist.
A lot.
Yeah.
They simply gave up. They are still printing those boards. They are still selling them, but haven't made a single software release for them in years. So we are actually the premier supplier of the software running there. We never got a single cent of a donation from them, or any kind of support or engineering support or anything. Right, so it's really a community effort at that point. Like Igor said, there are some boards that we are a bit more confident about that they can run, that they can take misuse, and you're not going to brick them by flashing to the wrong thing, and that kind of stuff. And then there's unfortunately a great mass of those boards that, I gotta say the truth, you want to play, it's a great way to learn. It's really nice. You get one of those boards, you go into clone Armbian, see it building, understand what it is doing, what patches are being applied. It's a great way to learn. So I get this more and more. People that are know enough about kernel development, but don't want to know about the bootloader, that they can go a little bit into the kernel without having to handle the bootloader by using a framework like Armbian, right?
Yeah.
And so we see this across all the areas, especially in user space. So Armbian doesn't build user space. We use Debian user space mostly, like glibc and everything down from that. But for some of those silicon vendors, they have specifics like video encoders. So then it gets into Chrome and video for Linux and OBS and this kind of stuff. So it has everyone who has an interest in developing this has really a lot of leeway to go in and learn. It's really attracts this kind of stuff. If you want to be trouble-free completely, then stick with a vendor that only works with one silicon provider for all their boards, if I'm not mistaken. Broadcom and Raspberry Pi, they're the same thing essentially. So yeah, if you like your boards to boot up the GPU first and then activate an ARM core later, yeah, it's great. But I hope they move away from this model eventually, right?
Yeah.
Let's see. Broadcom is also not a company that's very well liked these days, so let's see how that goes.
Yeah. Okay, so question from the chat room. Mashed Potato says, last question thought. He wants to know, how does Armbian differ from Raspberry Pi OS?
Oh, completely. completely. In the end, it's the same, right? So Raspberry Pi OS delivers you an image, which is based on Debian. I think it's currently based on Bookworm.
Bookworm.
But they rebuild their user space to adapt to that. They insert a lot of utilities which don't belong in a normal Linux system. So if you look at that boot partition, it's a FAT32 MS-DOS partition with config.txt and whatever CMline things. So that's all adapting to their proprietary bootloader, which is out of reach for most of us, right? So we don't have the source for that. So they do adapt that. They do have their own utilities for tuning things. And most importantly, their kernel, the big thing about the Raspberry Pi Foundation is and the software they produce is that I don't know much, but if you take a well-known hat, I don't know, is it a shield or hat, whatever, hat, and you take the most famous hat, you will get support for that hat directly into that image. Right, so there's a kernel device tree overlays already baked into that. It's there's already an option that you can set somewhere that enables that thing.
That should also work.
I mean, that experience can only be curated if you really have a very small set of silicon to support it against. Right, and in the case of a Raspberry Pi, you can do with essentially the same kernel run on all the Raspberry Pi boards. So in essence, first, I think the Raspberry Pi Foundation has put a lot more engineering efforts, right, into the software than any of the other boards suppliers, but by far, right? They produce not only good and well-integrated, well-tested stuff there, but they also produce documentation and training materials and how-tos, and the forum is active. So it's really, if you don't like diversity, it's ideal there, right? It is. For us, one, we have no corporate sponsor. We are a community effort. We have 200x more different boards to support. So you can imagine that the level of polish and refinement is not the same. So you can go and get your hats going with any of those boards, because in the end, they're just I2C, SPI, UARTs, or SDIOs, or that kind of stuff. So you can make it work, but it's probably not pre-made for you and ready to go. So it's great learning opportunity. But if you really want something that's pre-made and ready to go, then it might not be ideal for you.
Yeah, but if things just work, it's not fun. That's also.
There's about a tinkering, right? To tinker with those things. It's it's fun sometimes.
It's like going with preset Lego. Is the same. You have a plan how to put things together, and you have an aeroplane running. But if you have just an open box of Lego set and you need to assemble something, it's more challenging and more fun. Because you need to really think wider. So this is more if you look on this diverse ARM hardware, it's weird boards, weird way of booting. But the end, if you add little, if you play little, you learn a lot.
Okay, so I want to ask some wrap-up questions, because again, we're past the bottom of the hour. It's been a great discussion. So quickly, if somebody wants to get started with Armbian, learn more about it, what is what's the best place to go to?
fix some board that it's not working well. Let's say that would be probably the easiest way. I encourage people when they come and they said, oh, this board which we don't, let's say, support officially, but we have it there on the download page. It's there. We don't know. It builds. Sometimes it works, but it's not official support status. And they complain it's not working. Try to get it working. So we have tools. We will help you. And sometimes people really put an effort. Just recently, some guy bring up one really cool hardware, Helios 64. It was it is a NAS. It's like a NAS case and Rockchip based hardware. But it was like the company went out of the business. We couldn't. It was immature software support, so we couldn't, let's say, bring it up and pay the bill. So it was, and we said we cannot continue. So, but the community,
I would say go to github.com/armbian/build.
Yes.
That's where you want to be. That's where we all live. There's also documentation repo, there's firmware repo and other stuff, but find the build repo.
GitHub
get building, get a Linux machine, try it out. You can build it for x86 if you don't have a board. You can build cloud images. You can build minimal images. You can build on ARM for x86. You can build on RISC-V for ARM. So it's really interesting to get into the build system. So this is what attracts, I think, most people. There's a learning curve, of course, but it's much easier than if you start with an embedded appliance system like Yocto or Buildroot or others. So it's quite friendly. We try to be friendly to users who are just trying this stuff out. And sometimes these users become developers. It's really fun.
Yeah. Is there a single board that is kind of the premier supported? Is there one that you would suggest somebody starts with? If somebody says, I want to run Armbian on something ARM. What's the board you recommend?
Rockchip latest probably would be, because there is a lot of people around.
Perhaps. There's a lot of interest on the Rockchip 3588 boards. So those are the But
there is still, let's say, a lot of things that doesn't work well. Perhaps previous generation would be safer start. So previous Rockchip 3566 or something like that.
The 3568s are working excellently. Yes, they're great routers. You can get boards that have 2.5 gigabit Ethernet, two of them, NVMe, SPI flash, and our boards that are costing about 60, 50, 70 bucks. So they're pretty cool. They're 4-core A55s, so they're not super fast. If you want to go to something that is more cutting edge, then get the Rockchip 3588s. Those are 8 cores. 4 of them are fast A76, I think. They go up to 32 gigs of RAM. So you can. There's people doing home lab clusters, Kubernetes clusters on this stuff. There's a lot of interest into this. So the kernel mailing list is bubbling with stuff about this stuff. So it's really cool. It is, of course, not going to be perfect, but you're going to have a lot of fun. And they're actually usable application nodes, right? So it's pretty...
I've got the Turing Pi 2 carrier with some Turing RK1, which is based on the 3588. I've got them here right now, and because there is a bug in the kernel when you use it with NVMe, I am trying to compile my own kernel, and partway through the compile process, it is repeatedly crashing the board. So that's what I'm fighting right now.
Yeah, get some cooling and get some good power. That's the first always stuff.
I don't know that it's a cooling or a power issue, but we'll see.
I hate to say that, but I've been proven that even if you don't think so, try a different power and try different cooling. And do try Armbian. I'm not sure. You probably heard of Joshua Hiek, who's doing the Ubuntu images, especially for the RK1.
I have actually. I'm in a Discord chat with Josh talking about some of these problems. He's been great.
Yeah, exactly. And it's very fun because this is when we 2 years ago, we decided to do this kernel for this SOC in a more disconnected from the build framework. So it has its own REPL. And this has attracted not only Armbian developers into that, but other distros and other projects are also using that kernel. So that Joshua had his own Ubuntu distribution that was much simpler, let's say, than Armbian. But then we ended up collaborating on this. And I'm going to mispronounce his name, Juleng Feng, which people know as Amazing Fates. There's a lot of really wizard level guys, Boogie, Ice Cream. There's some of those guys who are already a legendary level in their a level of expertise into those things, both in the vendor and the mainline kernel. So yeah, it's fun all the way down.
Yep, excellent. We are absolutely out of time, and so I am just going to jump straight to the end. I'm going to ask each of you our famous final 2 questions. We will we'll start with Igor, and then we will go to Ricardo. So Igor, I'm going to ask, what is your favorite text editor and scripting language?
Scripting language, Bash. The text editor, Joe.
Okay.
Or Nano. So
Joe or Nano.
Depends.
Gotcha.
I used VI as well, so I'm handy with VI.
A real Renaissance man there, where it comes to text editors. Ricardo, some question.
I'm forced to answer scripting then Bash, of course, but Armbian's written in Bash. If I could say Java, I would. And I do use IntelliJ JetBrains IDEs for literally everything.
Oh, okay. Yeah, I have spent some time inside of Android Studio is really where I got to use it, but that is a reskin JetBrains. So
just the same, the same stuff.
Yep, excellent. All right, thank you guys so much for being here. Was a lot of fun, and the hour literally flew by. And we will have to have you back in a few months and chat more and chat about what has changed. So thank you both for being here.
Thank you.
Thank you for having us.
Yep.
All Pleasure. Right. Thank you.
Yes. Doc, what'd you think?
That was good. That was really good. And I was going to say, it was a very fast hour and 15 minutes, actually.
Very much so.
You know, interesting stuff. And you didn't ask about the weirdest use that they had.
You sort of did. You kind of did.
You
stole my thunder.
I sort of did. Yeah, I know. I'm sorry.
We also ran out of time, though. We'll get it next time. I'm sure they've got some fun stories. I don't know. Last week we asked about that, and the guy's like, "Well, the most weird one I really can't talk about on the air, but maybe they have some of those stories too." I don't know.
Yeah, like the one where the guy got killed. Oh, we don't talk about that one.
Well, no, it wasn't quite that. But anyway, all right, Doc, you have anything you want to plug before we let you go?
Oh yeah. So look up KWAAI dot AI, I think it is. It's open source personal AI. Yeah, KWAAI.ai. I mean, it's this open source effort. It's all voluntary. It's a nonprofit. Kwa itself is a nonprofit. It's based on a South African word. And they have some hackathons coming up. I am the chief intention officer of that effort.
Fun.
They named me that because I wrote this book called The Intention Economy, which in part inspired it. It's a voluntary position. I mean, nobody's getting paid right now on this thing, but it's fun, and I really love to see people get interested in it.
Yeah.
So open source personal AI.
Yeah, you got to hook us up for an interview. I tried to reach out to.
We'll do that.
I tried to reach out on one of the social media networks, the one Microsoft owns, which. The business one. I forget what it's called.
The business one, which the busiest one there is.
Anyway, so I tried to reach out and haven't heard back. But if I've got the,
I'll do the reaching, and I may do it in 10 minutes when I'm on a call.
There you go.
With them. I'd like to get their top tech guy on there. To talk about it.
Yeah, that'd be great.
And it may be early in some ways because it's such a work in progress right now. Mm-hmm. But we should do it. We'll do it. Make it happen.
All right, very good. So coming up for the show, we have next week is Amber, actually, which it's interesting that both of our guests today said that Bash was their favorite scripting language. Amber is a sort of a more structured scripting language that then compiles down to Bash code. It's really fascinating stuff. I'm looking forward to that. And so that is next week. And starting in July, so starting next week, just so you know, we're going to be doing the recordings on Tuesday. We're going to give that a try for a month, and if it works well, we're going to move to Tuesdays because that's going to take what I have about 6 hours to get done and give me 30 hours to get it done. And so my stress levels are going to go down if we can record on Tuesdays. It's going to be great. If you want to find me, my work, there's, of course, everything on Hackaday. We've got the security column goes live on Friday mornings. And we are now bringing the show with some video on YouTube, so you can find the Floss Weekly YouTube channel. Now, if you search for that on YouTube, you're going to find two different things. You're going to find the Untitled Linux Show, which is my show over on Twit, because we sort of inherited the Floss Weekly YouTube channel from them. And then there's the actual Floss Weekly YouTube channel, which is just this show. So go subscribe to both of those. That's what you should do. All right. Thank you, everybody, for being here. Those that caught us live and those that will get us on the download, we sure appreciate it. And be back next week on Tuesday for Floss Weekly.